All right, welcome to Gears of Resistance, episode number 13 for something like the 30th of August, 2015. And yes, I know I have not been keeping to our schedule, and that's not likely to change anytime soon because life, and it's crazy. But we're got some things coming up, so I did want to share a little bit and actually have this is a serve as a dry run for a presentation or the training I'm going to try to give, we'll be able to give. And so this is kind of like you're my guinea pigs, and I'm going to see and take notes about how well this works and what I need to emphasize and what I need to remove. And I figure doing something like this is a good test run instead of just sitting and giving a presentation to a mirror and myself or something like that. Anyway, so it's been a few weeks and we're still cruising along. I've been playing around with a project I can't talk about too much, but it is built around the new LaunchPad that has the MSP 432 from Texas Instruments. I have played with it in Code Composer Studio and in, I guess I've been pronouncing it wrong. I think it's Energia, but I think there are videos I was watching, it's like Enegria or something like that, which I guess sounds Italian-ish. I'm going to probably just stick with Energia because I like the idea of energy and all that. Anyway, so the project I'm doing is it's not necessarily taking full advantage of all the, I think it's an M4 ARM Cortex processor. Which is quite powerful. I think it's floating point units capable. So I'm not quite taking the full horsepower of it, but I do like the fact that it has in Code Composer Studio, there's a little kind of like energy, I think it's called energy trace. And you can actually kind of watch in real time as you step through your code how well you're doing with are you sipping power or are you chugging it down? So that's pretty cool. And it's cheap. I think these are like $12, which for Texas Instruments, like you compare this Texas Instruments company to like Arduino. Arduino makes their livelihood off of their Arduino boards, whereas companies like Texas Instruments, they're a bigger parts manufacturer. So for them, these boards I think are probably kind of like loss leaders where, yeah, we get you into the community and then hopefully over time you'll buy enough of just the chips themselves to go into your project that the dev board is kind of like the gateway into their ecosystem. And I think there's some goodness in there. A couple of years back, if you had asked me, okay, Arduino versus, I don't know how long LaunchPad's been around, but a TI product, MSP 430s. I would say, yeah, stick with the Arduino, especially if you're a maker. DIY, where you're not concerned necessarily so much about maximizing performance. You kind of almost you just want to get something done and built. But that's not necessarily true anymore. Even on price point. I mean, these guys are cheap enough and they're becoming easy enough to use where you really could build final solutions just on the boards for, again, not necessarily a professional consumer grade product, but for like a DIY maker kind of grade project, pretty good. With that though, I'm very partial still lately to the Photon, which I've been playing the Wi-Fi Photon. I think there's a 3G version. I don't think they call it the Photon. It's like the Electron or something else. But this is basically, think of it like an Arduino with built-in Wi-Fi, but a very powerful ecosystem behind it. A lot of good APIs to allow for we call them REST APIs, RESTful APIs, to kind of really do really cool whiz-bang Internet of Things kind of work, and almost make it kind of almost like drop dead easy. Like I said, I'm not a web developer or even, you know, fancy GUI kind of stuff. But the Photon has been pretty good. And if you're doing the Photon but you want something with Bluetooth, I haven't played with this as much as I would have liked, but there's a battery-powered kind of similar concept called the LightBlue Bean. I think I mentioned it a while back, and unfortunately I just haven't got around to doing as many projects as I would like. But you know, the same thing with, like, there's a common thread in all these, is that, you know, everyone sells the dev board, but everyone is also now selling, you know, just, you know, that tiny little board up here that has basically, you know, it's the microcontroller with, you know, the wireless connectivity. So the idea is, yeah, you build something, you test it, you develop it here, but then when you're ready to go to production, you can just buy a tiny little chip and, you know, make your project even tinier. Especially, you know, in today's discussion with wearable stuff, you know, this is a little too big to be worn. Maybe not quite. Maybe it is decent enough. That's compared to my the original Pebble smartwatch. So, you know, these things are not. Actually, it's probably just about as thick. So, you know, we could do full development work with one of these things. You probably wouldn't. You probably want to go a little bit smaller and optimize. But if you're doing one-off projects, like you're doing, I don't know, you're doing something for like cosplay, or I don't know what other kind of Halloween costumes, these things are pretty cool. And then last week we talked about the milling of PCB or circuit boards. I guess they're not printed circuit boards; they're milled circuit boards, MCBs. I'm still playing. Haven't had a lot of chance because I've got other work to be done. I am noticing some interesting, I'll say, a patina growing. I don't know if that's just because I was munching and working on this, or if this is just the oils off my fingers are naturally kind of corroding. I haven't really checked to see if it affects the conductivity. I'm sure it does. But that's something, I guess, to pay attention to. I don't know if you can see it, but yeah, there's a little, it's like a browning, little black. It's because I've handled it, because I've looked at my other circuit, like the blanks that I still have that I haven't used, and they're not showing any sign of degrading, but the ones I touch, I think the oils may be affecting your finger oils. So just keep that in mind. I don't know if anyone knows if there's I don't know if you can do a coating or something afterwards to protect it, but anyway, all right, so let's jump into what we were going to talk about today, and that is wearables. And let me jump on over to here. All right, so this is like the first draft, rough draft of a little slide deck, and it's meant to be kind of very graphical, not a lot of words. In fact, there's probably more words than I would like on some slides. But like I said, it's a start. So like I mentioned earlier, going to kind of be my guinea pigs for this, and I'm going to just kind of walk through how I think I would do this in front of a live studio audience. All right, so wearables. And again, let me back up. This is going to follow some other presentations where people talk about electronics in general. So the idea is people with no electronics or engineering background come in, they learn a little bit about Arduinos, electronics, electricity, and at the end of it, you know, we talk about, like, you know, the Uno, and we want to start showing them how you can take those same concepts and find boards and materials and components that are more friendly to wearable projects, and take your lessons learned and just use different components to make wearable projects. So that's the background. All right, so basically, you know, we've learned about these. The mouse doesn't show up. Or does it? Maybe it does. So we've learned, wires, potentiometers, Arduinos. We can replace those components with more wearable-friendly things like is similar to a variable resistor, except it's a little nylon cord and two gator clips on the end that as you stretch it, the resistance changes. You replace the wires with conductive threads. And then there's Arduinos that have a form factor that's much more friendly to wearables. And you take all this stuff and you can make cool things like this that can be worn, hence the name Wearables. So why is wearables suddenly a thing? Even though wearables, you've had pedometers you could wear for 30+ years, digital watches, the old Casio watches. So I mean, I would consider those wearable electronics, right? It's nothing too fancy, but I think yes, there's going to be those fancy consumer grade products, the Apple Watch, Google Glass. But I think the real interesting wearables are going to be in that DIY maker kind of world, where it's not commercial solutions. It's because think about it. Not that I'm a fashion guru by any sense. I wear a lot of T-shirts and shorts and flip-flops. Fashion clothing it's a very personal statement. It's this is who I am. It's used to express your individuality, opinions. And so, consumer grade electronics, though, is kind of the opposite of that. It's yes, you can change out the watch band, but there's only so much customization you can do. Yeah, you can change to maybe the clock faces, but real wearables, DIY wearables, let you express so much more. And I think that's why it's an attractive skill set to learn. So it's a blending of art and technology. If you consider fashion to be artistic, wearables allows you to create something that is both useful and beautiful. And again, it's a personal statement, just clothing, fashion in general. Now we can add digital electronics to that and take it up a notch. So for the most part, wearables is quote unquote electronics, except for a few changes. First of all, the components are built a little differently. In fact, I should probably make that say are built differently. Because the components, the underlying physics, my keyboard's being the underlying physics is still the same. It's just how they're, maybe I should say create, because I'm using construct or built. No, we'll go with that. Then the circuit construction. So let's make that circuit construction. Okay, so you're not wiring and soldering up, you're sewing your circuits together. That's a little different, and there's certainly very unique things that you have to consider, both the electrical properties and mechanical properties of different materials that you wouldn't use in traditional electronics. We don't use a lot of fabrics or a lot of things that are comfortable to wear or should be comfortable to wear. So that's going to require skill sets above your normal electrical engineer that you would learn in either on your own or in college. The fundamentals of good circuit design, though, and programming are the same, especially if you're going to use a microcontroller. You're probably doing some software. Good design techniques are still good design techniques for software, and good circuit design is still good circuit design. All right, so what are the popular wearable microcontroller platforms today? For the most part, from the sense when I go out and not just what I read on the internet, but when I see people actually building projects, everything I see is a Arduino, LilyPad, or a derivative. So LilyPad is or was the official Arduino wearables. I think in this post riff with the Arduino LLC versus the Arduino/Genuino crowd, Adafruit has their Flora, and I They're the even smaller version, the Gemma. Those seem to be becoming the more de facto. And then, of course, there's the Lily Tiny, which again is like the Gemma from the Arduino LLC crowd. So anyway, bottom line, Arduino, and I think it's for what, two reasons. Yes, they had first mover advantage, but because a lot of people that are doing wearables are more concerned, and it's just like, you know, a lot of other projects in general. People that are doing wearables electronics are probably more concerned about the fashion and the look than they are the electrical engineering or software engineering. And so Arduino offers you the chance bang things. Yes, they may not be the most optimized code, but you can get the job done. And I think that's what attracts that crowd to the LilyPad and Flora ecosystem. All right, so one thing to notice, one of the biggest differences is we don't have header pins, female header pins, male header pins. What else kind of connectors do you have? That's screw terminals. The big thing with wearables is sew holes. Sew holes. So in other words, it's basically it's copper exposed, and with a hole drilled through that allows you to take your conductive thread and sew many loops around it, so you get a good snug fit both electrically and mechanically. And that is kind of like the de facto connector for wearables. So I think this is a GPS module here, because that looks like a little antenna jack. Coin cell battery, again, sew hole for connector, and an LED board, and again, sew holes. So sew holes are kind of like the fundamental connector of the wearable electronics arena. All right, so let's talk about a couple of different components. So again, earlier you would have talked about things like potentiometers, variable resistors, and all that whiz bang, traditional electronic stuff. Now we're kind of finding what are the analog, what are the corollaries in the wearable world. So a variable resistor, we have conductive stretch cords. So again, as I pull the cord apart, the resistance decreases. So now you have a variable resistor. So you can kind of think, okay, well, anything I do with a normal potentiometer, with a stretch cord. So as I stretch, I can tell maybe when someone's opening a bag by, once I decrease the resistance, I can measure that resistance with a voltage divider circuit. Once my voltage either drops or reaches a certain voltage, I know that the cord has been stretched to a point that it's probably open, and so you can maybe make an indicator for that. Anything that you did with a variable resistor in the electrical world, in the normal, I'll say the normal electrical engineering world or circuit design world, replace that with a conductive stretch cord, and you can do something similar. Just perhaps the use cases are different. All right, a soft potentiometer. So here it would be a 3-terminal device like down here, A, B, and C. B being the center wipe, or the wipe, and A and C being a fixed resistance. So as you turn the knob, the resistance between A and B and C varies. The resistance between A and C always remains constant. So if you get like a 10K potentiometer, the resistance between A and C will always be 10K. The resistance between A and B and C will change as this is turned. Well, you can do something else similar with a soft potentiometer. Basically, you have a piece of conductive cord. So this would be part A. One end is part A, one part is C. No matter what I do, the resistance across it will always be the same, A and C. But then I take this cool little conductive loop, I thread it on to side of A, and as I move it around, the distance between A and B will vary. Therefore, the resistance between A and B will vary, and therefore, the resistance between B and C will vary. So when A and B is kind of close together, the resistance should, in theory, be kind of small. And as I move it further away, the resistance between A and B should increase. So now you have a 3-port potentiometer. Conductive hookup and loop, what we call Velcro, but Velcro is kind of like the Kleenex name. It's the commercial name, but the generic name is hook and loop. but we'll just call it Velcro because that's what we all know it as. So it's Velcro, nothing really different there, except it conducts. So you could sew a little bit of a conductive thread to either side, and when the hook part touches the loop part, you will basically, the equivalent of a knife switch connecting, it's a switch, and now you've completed the circuit. It's now conducts. And then when vice versa, when I open the switch, or when I take the hook and remove it from the loop part, it breaks the connection. So you can use this for, again, hook and loop can be used as a wearables version of a switch. Electric luminescence wire, tape, or panels. Basically, it gives you that, what's the Tron look. It is basically tape. Again, it's either thin wires, or these kind of like, imagine like a piece of tape. They even come in little like square or rectangular panels that when you apply electricity to them, they give off a glow, and they have that really unique look to them. They are cool. The only issue with them is they require alternating current. Alternating current, as you know, is the stuff that comes out of your wall outlet. It's not the stuff that gets put out from battery or photovoltaic cells. So there is something called an inverter that will take the DC of batteries. So here's two AA batteries, and what it will do is this little, and here there's a little electronic select components that will take the DC and convert it into the AC that's required by the electroluminescent wire to operate. So just keep it in mind. It's not something you can power directly off of a micro. You will need an inverter device to power that up. Pressure sensitive fabric, which has many different, I think, brand names. One is Velostat. At least that's how I think it's pronounced. Basically, it's a piece of fabric. It almost has a leathery kind of feel to it. Maybe, oh, went back. And as I press down in different parts, the resistance will decrease. So a lot of things, you can do pressure sensors, you can do buttons, you can do all kinds of things that where you measure, as I press down, I can vary the resistance across it. Sewable snaps. All right, so obviously, you know, it's one thing, you know, certain components of wearables are pretty cheap, where you use it in a project, you know, and the thing is, when you sew stuff together, it's kind of permanent. It's not like a hookup wire or gator wire that you can easily take apart and breadboard. Wearables is kind of a little bit more of a commitment to sacrificing your components for reuse. And while that works for certain things like you know, cheap LEDs where you can get them really cheap, things like your microcontroller or a GPS module, you know, you're talking, you know, $20–30, where, you know, you may want to not, you know, sew that or have to constantly resew it every time you want to change it between different projects. So this is where sewable snaps come in. The idea is one side you go ahead and solder one side of the snaps to your microcontroller board, and then you sew the other side to your fabric or whatever, and then you simply snap it on, and then when you're done, you take it off and you can move it to another project. And it allows for components to be reused across projects really easily. I have also seen people kind of alternate the male, female, or put like two females and the rest males, or vice versa. So that way, you won't ever, because a lot of these boards are circular, and they're kind of sometimes the sew holes are very what is it, repeatable, and that's the word I'm looking for. But you could potentially you know, kind of hook this up incorrectly. So what I've seen a lot of people do is a way to kind of like, with wires and cables where they're keyed, alternating or change or having some sort of pattern to the of the males, you can help prevent accidentally plugging your board incorrectly onto your wearable project. So just keep that in mind. All right, so that's kind of a deep dive, and then just so that everyone, I'm not going to go through everyone individually, but just know that there are tons of what's called breakout boards, where people have made little circuit boards that take electronic components, an accelerometer chip, a button, a light sensor, and they have put them on a board and made it very easy to sew these together in a wearables project. So you don't have to design your own circuit board or figure out ways to hook up these things to your wearables. These sewable boards make it pretty darn easy. So again, if you wanted to hook up a buzzer and a temperature sensor so that once say you put this on the top of your hat, and once you've reached a certain temperature, the little buzzer vibrates in your hat, so to maybe you've been outside long enough, you need to go inside and take a break from the sun. This just makes your life so much easier. And again, if you wanted to, if you're so inclined, you could always put little snaps, sewable snaps, and help to reuse these components across multiple projects. Boom, boom, boom. All right, circuit construction. So again, there's wires, breadboards, all that stuff gets thrown out. And in the world of wearables, you'll have things that you'll have to use like conductive thread, conductive fabrics, conductive ribbon, and they will all. And the thing is, there's different properties. So the resistance per linear foot, the amount of current they can handle, all these things vary. So when you're building a project, you're gonna, just like you figure out what size resistors and capacitors you need, you kind of got to do your homework, because there's not just a universal conductive thread. And you should probably, when you're starting off, maybe buy a couple different varieties, and that way you can experiment and see how different threads, different fabrics work in your circuits. So just word of warning, there are differences between manufacturers, and even within manufacturers, there's different properties within their products. One conductive thread is not the same as the other one. The big one with thread especially is the resistance per linear foot. Same true, I guess, that would be with the conductive ribbon as well. And then the fabrics, well, even with thread too, I guess the threads and the fabrics, is that there's different mechanical properties. So some are stiffer, which make them harder to deal with. Some are more pliable and easier to bend. So, whereas that matters a little bit when you're doing wiring of traditional circuits, when you're trying to sew something together and have a certain look, you got to consider that there is not just electrical property differences, there is, I guess, mechanical as well as aesthetic differences. So again, the best way that is to experiment, and as much as you can afford, try to buy a few different varieties and experiment with them. Sugru, what I call the new duct tape. It's a little expensive right now. I'm assuming it's patented. I could be wrong, but it is a self-setting rubber. So in other words, you get these little packages, you rip it open, you take the Sugru. It's kind of very pliable. You bend it to whatever your need is. So like, you've got people here making things to repair their MacBook cables, a nice soft handle for, I guess, looks like a hacksaw, repairing your boots. And then what happens is, with enough time, that Sugru kind of sets, and not necessarily becomes hard, but no longer is bendable, pliable to your desires. It gets fixed and set in whatever shape you've got. So very, very powerful, very cool, very good for, especially for wearables, where conceivably you're going to have a lot of the guts inside of, like, say it's a jacket, you want to protect that. but they're going to say you want lights on the outside of your jacket. You've got to protect the penetrations from the inside to the outside. So if you're out and about and it starts raining, Sugru is a good way to kind of provide an insulation between, when you're trying to keep things from being affected by the elements. Let's see here. So this is a little, friends don't let friends use wires for wearables. There's a lot of other options. Another one is electric and conductive paint and inks. If you're trying to draw a circuit, that's another possibility. It's also good for kind of if you want to do some repairs. So again, it's another thing that I've played with a little bit, haven't really found use cases for the type of work I do, but it's an option out there and I wanted to throw it out. So what are some projects? So this is one I'm going to actually try to hopefully build in these classes that we're going to do. Basically a little coin cell battery, little resistor, LED, conductive thread all the way through, and all you do is some conductive fabric down here. Touch your fingers together and the LED lights up. So what I was thinking was, instead of having one LED, maybe get some high intensity LEDs, some bright ones, and it would probably take a little bit more battery or whatever, and put them across the knuckles, and then kind of like have an on-demand flashlight. And as you touch your fingers together, it illuminates when your fingers aren't touching. The LEDs are off. But there's also some other things, building a fabric button. So basically take some fabric, put some conductive fabric on it, give yourself a little spot to sew it on, then take another piece of fabric, cut a hole in the middle. That way it kind of provides a little insulation, and then when you press down here in the middle, the two ends of the conductive fabric touch and complete a circuit, and you've got a button made of fabric. And that's it in a nutshell. And so I wanted to highlight some people that I think are very worthwhile to follow, who do a lot of this work seriously and professionally, and are way more qualified to talk about it than I am. But so the two folks, Becky Stern, she works with the folks up at Adafruit, has a YouTube channel dedicated to Wearable Wednesday. It's a great resource for how-tos, product demonstrations, product recommendations. Then also Kate Harmon wrote a book with the good folks at Make on wearable electronics. It's pretty inexpensive. It's worth it. Again, has a lot of good tips, tricks, and project ideas. And then lastly, where do you purchase wearable components? You have Adafruit and SparkFun are probably my two big guy favorite ones. You can also go to Maker Shed. These are all, Google these and you'll find them. Most of them are, well, actually all of them are online, except for I guess the last two. Fine Silver Products, Less EMF, Bare Conductive Paint, which I think you can find at Radio Shack if you still have Radio Shack around. Lame Lifesaver, Inventables, Plug and Wear, Joanne, and then lots of Joanne Fabrics and Michaels are your, at least those are the two craft stores I have local to me. You probably have different ones in your neck of the woods, but for certainly not necessarily for the electrical parts of your wearables projects, but for the non-electrical parts, those are good resources. I will also point out that probably everyone knows I do occasionally blog and do some projects for Mouser Electronics, and they recently have started selling Adafruit products. So if you're looking to, and they've got, my experience, I think their pricing when shipping is a little bit better, just because they do so much volume. So depending on if they have the parts that you need, buying from Mouser probably will save you a couple bucks on the shipping. And plus the other thing is, you can buy a lot of other products that you necessarily couldn't get from Adafruit or SparkFun because they just sell literally just pretty much everything under the sun, in component wise. So those are my recommendations. So let's see here. I haven't really finished this up yet. So I'm going to also add, like, some other takeaways is weatherproofing with wearables is important, and also your stuff to be repairable, because it is being worn. It's going to have probably more shock and tension put on it than perhaps an electronics that sits inside a box. So you've got to just, wearables needs to be a little bit more robust, a little bit more repairable, and that's it. So sure, yeah. So that's it in a nutshell. So let's switch back over here. Let's see if this all works. So that's Wearables 101. Feel free to send a bunch of comments with things that you think I glossed over too much, too quickly, things I should present more in depth, or maybe I went too deep. I don't think so. I hope I didn't. And then just, this is what I would expect out of a wearables class. So send me those comments. I'd appreciate it. It can only help me get better in teaching, and then we can hopefully help everybody else learn better. Maybe a little less confused. Sometimes I confuse myself, and that's not good for anybody. So anyway, I guess that is going to wrap it up for this week. We're going to try to here shortly we should be doing Steam Power podcast this week, because I missed Gears Resistance last week. I think I did, at least. I don't remember. So we're going to try to do another one of those. If not, we'll catch you back up in a week. We may have to just flip the schedule around and just alternate the weeks back and forth. So anyway, anything else? Let me think. Any other stuff? No, I think that's it. Yeah. So head over to gearsresistance.com. There's links to everything else we do. The companion podcast, steampowerpodcast.com as well. And there you find links to everything else, and where you can leave us comments, feedback, and all that good stuff. So with that, let me bring this over here. Thank you all very, very much for listening. And until next time, keep it makerish, DIY it, do it yourself. Get out there and make something. I don't know. But if nothing else, stay quirky. Thanks for watching.